Hello everyone, welcome back to our IGCSE Math 0580 Extended Revision session. This session will be doing Unit 5, Mensuration. To start mensuration, we first need to know the units. The most common units we can see are meters, meter, centimeter. This is for length. And for weight, we have kilogram, grams. And for volume, other than meter cube, centimeter cube, we have liter, liter, and milliliter. Milliliter. Sorry for my handwriting. So the standard units are meter, kilogram, and liters. And in different measurements, we all have the same prefix. So we have small m, milli. This means 10 to the negative power of 3. For example, if 1 millimeter, mm, will have 0.001 meters. And if we have 1 milliliter, milli, right, we'll have 0.001 liters. If we have a milligram, we'll have 0.001 gram. And centimeter is 0.01 meter. This is all you need for math at IG level. And in questions, we need to do conversions. For example, convert 15 millimeters into meters. What we'll get is 0.05 meter because 1 meter is 1,000 millimeters. And also, you know that liter and milliliter, two L's, sorry, is 1 liter is 1,000 milliliter. And 1 liter is also 1 decimeter. Decimeter is 10 centimeter, or 0.1 meter. And 1 millimeter equals 1 centimeter cube, because 1 decimeter cube is 1,000 centimeter cube. And now area and perimeter. So some common shape you need to know. For example, square. And in quadrilateral, we have parallelogram, rhombus, kite, rectangle. And triangles. Triangles are just triangles. And circle. And this is also in quadrilateral. Trapezium. So for quadrilateral, the most basic formula is width times length, which works for basically all quadrilateral. For example, square, width, length, width, length. And for parallelogram, this is the length and this is the width. Because if you cut it, you see it as a triangle and you move it here, you will complete a rectangle. And for rhombus and kites, we see it as triangles. And this is the height, and this is the base. So for a rhombus, we just half height times base times 4. And for a kite, we have this one, which is, for example, base, height 1, height 2. We'll have base times height 1, half times 2, plus base times height 2, half times 2. And for a trapezium, this is base 1, base 2, and height, perpendicular height. We'll have base 1 plus base 2 whole thing times height divided by 2 times half. And for triangles with the height and the base, we'll have just half base times height. Just remember that the height is perpendicular to the base you're chosen. If this is your base, for example, this is base 1, you'll have to use height 1. If this is base 2, you'll have to use height 2. Now what if we have a obtuse triangle, looking like this? And this was, if this is your base, this will be your height. Base is only till here, and height is here. Or you can rotate it with the longer side on the bottom, then this whole thing will be your base, and this will be your height. Now circles. You don't need to know radius for 0580, so you just need to know circle with radius r. The area of the whole circle is pi r squared. Now moving to perimeter. For squares and rectangles, oh, this looks like also a square. Let's draw it like this. Let's just square. We'll have width plus length plus length, both for square and rectangle. And for a parallelogram, if we know the side 1, this will be also side 1, and side 2 is just the same as a square. If we don't, you may be given, for example, the height and the length here. Then we can use Pythagorean theorem to calculate the side length, and that works for the same for rhombus and kites. Now trapezium. Trapezium, you usually be given the top base, bottom base, and if it is regular, so like these two sides are equal, what you can do is base 2 minus base 1 divided by 2. This will give you the length here, and use the height. Use Pythagorean theorem to calculate this slant height. Now triangles. Triangles are just side A, B, C, just B plus A plus C. And circles with radius r, you'll have 2 pi r, or can be also written as pi d, where d is diameter. Now arc and sector. This part is only for triangles. We'll have a circle, center here, and radius r. So what is an arc? Arc, for example, this is an arc. An arc is a segment on the circumference. For example, we have an arc here, and let's say this is 60 degrees, alright? So if we want to know the length of the arc, we can see this as a fraction. The whole cycle is 360 degrees, and this is 60, so here is 300 degrees. And the arc, as a fraction, would be 60 over 360, and then just times the whole circumference, which is 2 pi r. The same logic works with sector. If we want to know the area of this sector with a degree of 60, we'll then just have 60 over 360 times pi r squared. So if the angle here will be theta, we'll have just theta over 360 times whatever it is asking for. If it's circumference, well, if it's arc, we'll have 2 pi r. If it's sector, we'll have pi r squared. Just see it as a fraction. Now surface area and volume. So for example, a cuboid. Or a cube. Let's say this is a cube with width w. The area, again, we've done this in the previous session, which is w times w times w. If it's a cuboid, we have width, length, height. It will be w times h times l. This is for cuboids. And when we open their net, which means open it to a 2D surface. So sorry for my drawing and scaling, but it would be something like this. 1, 2, 3, 4. Yes. Okay, it'll be like this. Or for example, if we have set A, B, C, and D on the bottom, E on the side, F on the bottom, this will be the back, sorry. So if we have A here, this will be C. This will be E, we'll have D. Oh, sorry, here will be B, and we'll have D and F. And now the surface area, we'll just add all these cubes or rectangles, whatever it is. So since, let me draw a better one. Okay, A, B, D, F, C, E. So we got the width, the height, the length. We'll have here being W, L, W, W, L, L, L. Oh, here will be H, 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 L, L. And this will be also L, 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 and H, H. So the whole surface area of this cuboid, we'll multiply them together. So we'll have for D, WH, B, WL, A, WH, C. This is H, yeah, HL or LH, E, HL, F, WL. And add all 6 together will give us the surface area. This is for any kind of cuboids. If we have, for example, a parallelogram with width, something like this, right? So we'll have side A, side B, side C, and when we open it, we'll have the longer side B, side C, looking like this. Here is side A. Here is another one, and another one, and the one corresponding to A. This will be a rectangle. Rectangle could be a square, could be a rectangle, and 2 parallelograms. Just use the area we've talked about. Now move on to harder ones. We have cone. A cone is just like a triangle, but with a base of a circle. So this will be base, and given height is perpendicular to the base, with its end at the center of the base, height h, we'll have 1/3 base times height. This also works for a pyramid. For example, a square-based pyramid with its base square, the center center h, sorry, base. And base for a circle, we already know. Here is r, we'll have pi r square. For a rectangle or a square, we'll have w times l, 1/3. And now prism and spheres. Prism and cylinder. A prism is just a long triangle, I guess. So we have h, base L, height here. Sorry, this is already height, then call this length, I guess. So we have first calculate the triangle and times the h. We already talked about it in the last session. Just think it as multiple slices of triangles. So we have b times L, half times h. And the same logic works for cylinder. Think it as a circle with multiple slices. So if we have r and h, we'll have pi r squared times h. That easy. And the perimeters for these. So first we have, let's do the cone. The cone, when we open it to its net, it will be something like this. It will be a sector, and thus its circle base. So we have r, and this sector will be the circumference of the circle. So we already know that theta, here will be theta. It may not be just a semicircle. Could be something like this, or it could be something like this. So we have here theta, theta, and we know that the area of a sector is theta over 360 pi r squared. So we just need to know r here. And how can we know the r? We already know that the arc length of this sector is the circumference of its base. And the circumference of its base, let's say big R, and we have small r here. The circumference of its base is 2 pi r, small r. And the arc length of the sector would be theta over 360 times 2 pi r. So we already got the formula. We have theta over 360 times 2 pi r equals 2 pi r. And we now just need to know the big R. How can we know that? The big R is the slang height, which is here. And we already have h and r. We'll just use Pythagorean's theorem. A squared equals b squared plus c squared in a right triangle. That will be, then we can get theta and r, which is then solved. And it's a little bit different for pyramids. For a pyramid, that looks like something like this. Let's say this is a square-based pyramid. It would look like this with its base here. And we have, since it's a square, we'll have just W, 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 and W. So we have height. This is W. This makes it half W. Pythagorean theorem, get the same height. And this will be L. Same height, S, then. Then we'll use the area formula for triangles. Half base times height. In this case, base here is W and height here is S. And now, prisms and cylinders. Prism, its net looks something like this. 3 sides of rectangles. And it's triangle base. So just triangle, triangle, rectangle, rectangle, rectangle. We already have H, we already have base and L. Here is B, here is H, H, B, H, B, B, H, B, B. And we have L, we have L. So just H times B times 3, because we have 1, 2, 3, and then 2 triangles. The same thing works with cylinders. We have, because it's not turning the angles, well, looks something like this. Here's circle with R, and H is actually here. Now, what about the width? The width is the circumference of the circle. So here is actually 2 pi r. So 2 pi r times h plus twice pi r squared. Now the last one will have sphere. Let me try make this looks like a 3D sphere. We'll have r. And this is also r. No matter where, this is r. And our formula for its volume is 4 over 3 pi r cubed. And its surface area is 4 pi r squared. Now compound shapes. For example, we have a rectangle, a triangle, and another rectangle. If we have 3 centimeters here, and we have 2 centimeters here, we have another 4 centimeters here, we have 2, we have a 6. Like this will be given in the test. And here, let's give it 15. So what we can derive from the given information. So first, the surface area of this little rectangle would be 12. The big one. So since the whole width is 15 minus 6 minus 3, we'll have 6. 6 times 4 plus 2 will have 36. Oh, it's actually a square. Sorry, my bad. And since this is a 4, this is a 2, and plus equals 6, this is 6 minus 2. We'll have 4 here. 3 times 4 times half. The area here would be 6. So 36 plus 12 plus 6 is its surface of its area. If we're asking for perimeters, we'll have 6 here. 4, 2, 6. We'll have 2 plus 15. Let's write it here. 2 plus 15 plus 6 plus 4 plus 6 plus 2. Let's then have Pythagorean theorem 3, 4, 5 plus 5. Now, for example, we could have like an isosceles triangle with a semicircle, and this would be the diameter, and we have height of the triangle. The perimeter is half d, which is r squared, plus h squared Pythagorean theorem square root. This gives us the slant height L equals, and then we'll have to know the arc length, or half the perimeter. So this will be 2 pi r, and remember it's half, so it's 1 over 2. So just pi r. So the perimeter will be pi r plus L plus L. And for the area, first calculate the triangle. We'll have base times height times half, d times h times half, and then half the area of the circle. The area of the whole circle is pi r squared. Half it is just half pi r squared, and r is half d. So we'll have half pi times d over 2 squared. Now compound solid. It's similar to compound shapes. For example, we could have a cube with a pyramid on top. So the surface area, if we have the net of this shape, we'll have the pyramid, the 4 triangles. Sorry for my scale, there should be all the same sides. And the cube, because one of its face is actually the base of the pyramid and is hidden inside, we only have 5 faces, looking like. And we'll just calculate the area of the either rectangle or square, and triangles. The harder ones are the ones with circles. For example, we could have, let's do it like this. We could have like a ice cream shaped, raindrop shaped, which is half a sphere with radius r, and a cone with height h. We just see it as 2 separate solids, so we just calculate half the sphere. The sphere is 5 over 3 pi r cubed half times half, plus the cone. Cone is 1 over 3 pi r squared. So this is the volume. And the surface area is first half the surface area of the sphere, which is 4 pi r squared, plus the surface area of the cone minus its base. Remember, it's inside the solid. It's not counted as surface area. So we'll have pi r times r plus L, where L is the slant height. Yes, this is the formula. And the last one, the frustum, is a either pyramid or cone with its top chopped. So you can either, if it is a pyramid frustum, we'll have h over 3 times s1 plus s2 plus square root s1 s2, where h is the height of the frustum, h, and s is the surface area of its top base, and s2 is the surface area of its bottom base. And its net looks like 4 trapezium connected with a square on the top, either square or rectangle on the top and on the bottom. So the surface area will be just trapezium, 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 rectangle, and rectangle. And if it's a cone frustum, you can use the whole minus part, or the formula would be pi h over 3 times r squared plus r small r plus small r squared, where small r is the top one and big R is the bottom, h is the first term height. And the surface area, even though we have a formula, but it would be easier for you to just see it as like calculating a sector, but minus subtracting the small sector, giving it the one we want, and just two circles with small r, big R. And that's it for today's. Thank you for watching.